Okay. Good evening, everyone.
Good evening, sir.
Still today, very
Good evening, sir. Good evening, sir.
good evening.
Good evening, sir.
Good evening. So today also very few people are coming. What's the problem? Math session, or some other thing? Okay. Okay. So you know, right? Today is solve with us. Week 12 session is there. I think tomorrow is your due date for submission, right? For week 12.
Yes, sir.
Okay. So all of you are in Python, huh? I saw some of you in Python also. I think.
No, at least I'm not.
Yeah, yeah, but some of you are there. I think. Maybe okay.
No, sir, I am not in Python. I have not taken.
Okay, okay, fine. Okay, so I'll share my screen. We'll start the session. I don't know, like others will join late or something, but we'll start the session and we'll see. Yes, you guys are able to see my screen, right?
Yes, sir. Now we are not
Yeah,
able to. Okay.
I'll just open the peer deck and then I'll share my screen. Okay, all of you are comfortable with Z-test, right?
Yes. So actually, my problem is I can solve the things and then I forget. That's my problem. I don't know how it happens. But for stats, it's happening like that.
Okay. So the okay, I understand, but why I'm asking this question is if you understand what is there in Z-test, you will be better understand T-test, F-test, and chi-square test here. So
Right, sir.
okay, so Z-test, what we do generally, Z-test we have samples, right? We have samples like x1 to xn, and they are from some distribution, right? Or maybe generally, let's say they are from normal distribution with some mu and sigma square. What we are testing for there? We're testing for mean, right?
Right.
That means the mean of a sample, or what will be our null hypothesis there? That mu equal to
You
some
were.
mu naught.
Yeah.
That is the test, and alternative might be, if it is right tail test, then it will be mu is greater than mu naught, right?
Right.
If it is left tail test, then mu is less than
Less
mu
than.
naught,
Yeah.
and if you say that mu is not equal to mu naught is some value, right?
Right.
Mu is not equal to mu naught, then it is a two tail test, right?
Yeah.
And then what we do, we'll define some test statistic, and in that case, test statistic will be sample mean, right? In Z test, so we are checking for sample mean. So let's say we are going for uh, you know left side test, then what will be my test?
But mu is
X
less than
bar.
mu not.
X bar is less than C, right? Because we are
Yeah.
checking
Right. Right.
for the sample mean, right? So X
Yes, sir.
bar, if X bar is my test statistic, then I'll check for X bar less than C. So we are going to find X bar. So we are testing for X bar less than some constant, right?
Yes, sir.
That will be, and what does that mean? Outside that X bar is less than C, so whatever is there, there will reject the null hypothesis. If your value of C comes in that region, will reject the H naught,
So,
right?
but I have a doubt here. No?
Yeah.
So whether I was just going through a problem sometime back. So the critical value, like it's always should be greater. If it is greater than critical value, only we will reject, right? So whether it's left or right it comes the next
No,
step.
no, no, no. It's not like that, right? Okay. So the thing is, if my x bar is less than c, if my test is x bar is less than c, then when I'll reject the null hypothesis at some significance level. Okay, that is another thing. Okay, okay. Maybe I'll try to show you here. Okay. So see, that's what. If you understand this, right, you will be able to understand this t test, f square test, sorry, f test and chi square test. So let's say my test statistic. So I'm this. This is I'm explaining for z test. Okay. So z test is for what? Z test is for testing mean, right?
Yes.
Testing mean with variance known. We know the variance, right? In this z test, right? Now our test in this case was will be uh, test will be what? Okay, what is the test statistic we use here in the z test? It is sample mean,
X X bar.
sample mean or x bar, right? So my test will be, if there will be three tests, right? So it depends on like what is our null hypothesis and what is your alternative hypothesis. So let's say my test is left tail test. In this case, what I'll say, x bar is less than c, right? This is correct.
Yes, this will be the alternate hypothesis.
Yeah. So okay. So my z test means what? It is a normal zero anchor, right? So it is having zero mean and one standard deviation, right? And what I'll say is whatever, if my c value, the value of c, if it is less than sorry, my if x bar is less than c, then I will accept the null hypothesis, and for other values I'll reject the null hypothesis, right? So this is the region where I can accept the null
So
hypothesis.
I was talking about, yes sir, I was talking about rejecting the null hypothesis.
Yeah. So
So when this I think like this will be derived, like for example any z test you are performing,
hmm,
you start from let's say you are asked to find the alpha and beta, like I mean, sorry, you are given the critical value,
hmm,
sorry, significance,
okay.
and you have to find out the for with the test statistics
Hmm.
you are given the you are taken alpha as the 0.15 or 0.10.
No, alpha
I
is,
don't
so alpha is what? Alpha is a significance level, right?
significance, yes sir.
That means or generally it will be like 0.05. That means with 95% chance is there that so we are not going to reject the null hypothesis, right?
Yes sir.
That means, so what is alpha? Alpha is probability that I will reject
Reject
h
H
naught
naught.
given that
H
h
A
naught
true.
is true. So this is the error, right?
H naught
That
is true.
means my, I said my null hypothesis was true. Still, I rejected the null
Allah,
hypothesis.
yes, sir.
So what is the error? It's, we are saying it's 0.05. So that means 95% of the time, when h naught is true, I'm going to accept the h naught, but there is some chance that I will reject h naught given that h naught is true. That is what alpha is, right? So okay, what will be the rejection region? That means, let's say if my, let's say so x bar is less than c, means let's say this is some c, okay, and my value of x bar lies or I can say is suppose how I'll say is, just a minute.
Sir, I was just a few couple of hours back. I was going through the 11.1 third question. So wherein I got the answer like, so only thing is my question here is the initial values that were given for f z scores. So one is we have to check for alpha 0.05 and alpha 0.1 for both. But from the table given from the values, we are not able. We are only 0.05 is given, sir. So 1 is not given. If you can see
Okay.
that data.
Okay, in the paper, in the this thing you are saying, right? You're saying about the solution, right?
Yes,
You're
sir,
not
yes.
saying about the concept you're saying.
No, I am talking about the solution. Yes, sir.
So solution, if you could, let's say it is not given in that assignment maybe, so
Yes,
you
sir.
can actually calculate from the table, right? That value for 0.01. So it will be like fz inverse of.
Yes, sir. That inverse, I am finding it difficult to find out how to go and check this
I think,
because
sir, see, there are two things are there. You can check in the internet also. So Z table is available there, or you can. I think Andrew sir has shown in the Google Collaborate how to find the values. So okay, one more. Maybe I'll show you how to do this.
because we are able to get the FC score from the value of Z, but the reverse inverse is really a problem actually. Z table. So
Okay,
let's
let's
say
say
if you want, yes, sir. Let's say
this
if you
visible,
want,
right?
yes,
Okay.
sir. This is
Okay.
visible.
So Z values are here, right?
Yes,
And
sir.
I wanted to see for what fz inverse of.
Let's say I want it for, I'll just tell you the value also, sir. Actually, Z inverse of, uh, say if you take for a Z inverse of 0.05 itself.
Not 5,
Yes,
right?
yes, sir.
Okay, so okay, first of all, are you able to find this value fg of 1.64? This is are you able to find this thing? So where you
Uh,
see, where will you
have,
see 1.64 is where?
so I'm first checking with the given in the question itself at the top, no, like initially
No, no,
for
it's okay,
reference.
it's okay, but how to find
If
it
it,
from the table?
yes, sir, first you will have to go for the 1.6. First, go to
1.6
1.6 and then 0.04. Is it right?
and here, right? So here 1.6 and this will be the value, right? 0.50 something,
Sir,
0.05.
but this is negative, sir. Actually, we are looking at negative Z.
That is okay, right? Negative means like if you find on the other side, it will be 1 minus this value.
Yeah, I think if you scroll down, we can see the positive one, right? Scroll
Positive
up
or
or
not,
scroll up or scroll down. Actually,
it's okay. It's okay. You'll be able to see anyway. 1.6 is what?
1.64, 0.04. So we have to go to
That is
the
okay. That is
fifth column. Yeah, okay.
yeah. Either you can say 1 minus
Yes, sir.
0.05. It will be,
0.949,
it's,
94950.
since it is a symmetric table, right?
Yeah, yes.
He is symmetric, so it's very possible that you can able to find it very easily. Another thing is this was fg of 1.64, right? If I wanted to find fg inverse of 1.64, what how I'll do is I will check in this table where my values. Let's say I wanted to find what you want to find 0.01.
05, 05.
01 or okay 0.5. So we'll check for where it is that 0.05 is in this values. So I'll go here, right? So 0.05, right? Where it is this value, right?
Yes, sir.
So this is corresponding to what? Minus
Minus
1.64.
1.64.
So that is your value.
Oh, okay, okay.
Okay. In the table also, I am not sure. Like,
So that is basically Z inverse of
yeah.
0.05, is it?
Yes.
Okay.
So I okay. Maybe you guys have grade assignment. Do you have the values given?
It's there. Some values are given, but
That is okay.
I didn't find this 0.05. That's why I was here. Yeah, if you look at this.
See, here if it, let's say fz of minus 1.09 is given as 0.13786.
Yes, sir.
So that means fz inverse of 0.13786 is what?
Minus 1.09.
Minus 1.09. Say, so you can check how it is coming. So let's say fz of minus 1.09. If I'm going to check minus of 1.09, where it is? Here, right?
Yes, sir. Last.
And if I wanted to find for 0.13786, how will I find? I will check for this value in the table and
Yes,
I'll
sir.
see corresponding
Z
z
value.
minus 1 and minus 1.09. That's
Sir,
what.
can you please find FZ inverse of 0.025?
Can you tell me where it is?
That's given in the table, sir.
Yeah,
That's in
no,
the question
no,
itself.
okay, that,
At the top.
0.025. How do we really find it out now?
okay.
0.025.
You can you identify 0.025 in this table where it is?
Where is that? 0.025 is 221. Here it is. That
Where?
is 0.6 and 1.9
Minus 1.9.
minus 1.96.
Minus 1.9.
96.
Is it? So you are able to find it, right?
Yeah.
So that's what. It's not difficult actually. It's very easy. It's
All right.
okay. Okay. So that's what. So
But we are going to get the values in the exam. We are
yeah,
not.
exam you are able to, but in general, if you wanted to find it, how will you find it, right? That is
So
the question.
yes, sir, that's what my question was. So here, luckily, like say for example, because we can when we are doing the assignments, we are able to go to Google or whatever. Sorry, it's a Z table. But particularly when I was doing this 11 point, I mean it's the same question for the two values. Like for example, alpha equal to 0.05, and then alpha is 0.1. So I was in the sample values given 0.05 was given, but sorry, not 0.05. Point Z value for 0.05 was not given, but 0.01 was given. So then it will become difficult. No, we can't go and search right there.
Why not?
So
In
it's
the
like
exam you are saying, or in grade assignment? Why
no,
sorry?
I'm talking about in the exam.
Exams will
If
provide all the values. Don't worry about that.
because here in the test itself it's not there. That's why we are
No,
looking at the table, right? That's
no,
why
no,
I was saying.
exam it is there. Exam everything will be there.
Okay, okay. Thank you, thank you.
Okay, so that's what what I was talking about is in Z test our test was we are testing for mean, right? Sample mean. And in other now in T test what we'll find, so what we are checking for, on again we are testing for mean, but here variance is unknown, right? Variance is unknown, the population variance is unknown, right? In two sample Z test what we'll do, we know the mean, but we don't know the two unknowns, right? So sorry, two standard deviations or two population variances for the sample means. We are checking for.
May I request something?
Yeah, yeah.
You are bringing some very nice points. It would be very good if we could actually note it down. Maybe if you can put it on the note or something, we'll just. I would like to copy it.
Okay.
Like
Okay.
how you're actually disassembling the entire thing, or putting a kind of a flowchart to identification.
Okay, fine. So we'll see this one. Let's say. So first of all, Z test is there, right? So Z test is this is one sample test, right? One sample Z test. So in this case, our test is for sample mean, right?
Yeah.
Or mean. We are testing for mean, right?
Yeah.
And here we what is known here? Sigma is known here.
No.
So what is this sigma? Sigma means population standard deviation, right?
Yes.
A population standard deviation, or you can say variance,
Yeah.
right? Or variance, I can say. This is known. So then we'll use Z test. Then for when we'll use T test is for also testing for means, right?
Yeah.
But here the thing is, here there are actually two things. One is the samples are less. So when we'll use this, when the sample is very less, and another thing is here sigma is unknown. Okay,
Yeah.
t-test is used for sigma known also, but in our course we are testing only when we are having sigma unknown, right?
Okay.
sigma or standard deviation unknown. So when we have very less samples, let's say below 30, in that case we'll use t-test. If you are having more than 30 samples, we are going for z-test.
Z-test. Yeah.
Right? But in our case, you can think like this: if we have sigma known, then we'll use z-test. If you don't know sigma, then we'll use what, t-test.
T-test.
Okay.
Irrespective of the sample size, right?
Irrespective of sample size for now, but generally
Okay, thank you.
people use in practical purpose, right? When we have lesser sample size, we'll use t-test. Okay.
But in our case, irrespective of the sample size, we'll rely on sigma.
Yeah,
that
if it is
given
if
on-
it is given in the problem that t-test is used, then you don't have choice, right? You have to use the t-test. That's what.
Okay, got
Okay.
it.
Okay. Then one more thing is okay. Another test is what? F test is there, right? F test.
I square.
Chi-square test. Okay. Chi-square test is there. Okay. So chi-square test is used when
When you're comparing variance.
comparing variance, but when we have what? It is for comparing
We
variance.
talk
So
about
that
variance.
testing for
Mean is not available.
testing for variance.
variance.
We don't compare variance. We test for
Yeah,
variance.
not compare. Test for variance.
Yeah, we don't
Okay.
compare.
Because
Okay, okay.
this chi-square test is a one sample test, right? Chi-square test one sample test. So we are testing for variance, and here mean is unknown, right? Then these are the, I think, 3 tests given for one sample test, right? Okay. So here what you will do is, here mu equal to mu naught is my null hypothesis. Okay, there can be a different null hypothesis, but generally our rule is what? We are going for simple hypothesis, right? So here h naught will be mu equal to mu naught. Ha will be what?
Mu is
Three
greater
types.
than not.
Three tests can be done,
Yeah,
right?
yeah.
And you will be able to identify, right, how to do this,
Yeah.
when to use, right? Okay. For t-test, again we are comparing same. This is my null hypothesis. Again, mu is less than mu naught, mu is greater than mu naught, and mu is not equal to mu naught, right? It's okay.
Yeah.
Okay. Here what we'll do in chi-square test? Chi-square test. Okay, my h naught will be. Okay, sorry, I will just remove this. I will finish. In chi-square test, what I will do is I will test. Okay, my null hypothesis will be, because this is a test for variance, so I can say that it will be variance or sigma. So I can say sigma square equal to sigma naught square, or sigma equal to sigma naught. This is my null hypothesis, right? And what will be my alternate hypothesis? Either it can be sigma is greater than sigma naught, sigma is less than sigma naught, and sigma is not equal to sigma naught. Okay. And okay, in this case, what is z? Z is what?
Not known. Sorry. Which
So
one are you referring to?
for z test. So
Mean
this is,
doesn't play any role. Mean does not play any role.
so it will be x bar minus mu upon sigma. This
Yeah.
belongs to z, right? Which is
Yeah.
not 0 1. Correct, right?
Yeah. X bar minus mu is sigma. Yeah.
Sigma by square root n, sir.
Sir, sigma upon root
Okay,
n.
okay, fine.
Yeah, by
You can
square
do.
root n.
But actually, so what I'm telling you is, okay, fine. So this is if you use the more number of samples, right? Like 30 samples or something. Okay, fine. That's okay. T-test is what? Represented by Tn minus 1, right? With n minus 1 degrees of freedom. It will be like what? T minus mu naught. T is what? Test statistic, right? Or
Yeah.
or I can say here again, x bar minus mu naught divided by what? S by root n. Correct? So
Yeah.
you can identify the difference, right? Here I used sigma, but I'm using s. So that means why I'm using this, because sigma was unknown in t-test.
Yeah.
Fine, right? Okay.
Yeah. Yeah.
So t-test is done. Here in chi-square test, n minus 1. So it will be n minus 1 divided by sigma naught square into s square, right? So I can how can I remember is this is s square minus sigma square into n minus 1 is belongs to chi square n minus 1, right? So if you come to this format, you can say that this is now this conforms to the chi-square test, right? So similarly, when we did in for z test, x bar minus mu upon sigma by root n, when I come to this format, I'll say this belongs to normal 0 1 curve. Similarly, if I come to this format, n minus 1 s square by sigma square, this can be said as this can be said that it is belongs to chi-square distribution, correct? This okay?
Yeah.
Okay. Okay. Next is two sample test, right? Okay. So I'll
Sample Z test.
yeah. So I'll go on next page. So two, sorry, two sample test. Okay. So in two sample tests, what we'll do? Which are the two sample tests? One is
Z.
G.
two sample Z test.
G.
Okay. This test is used for comparing
Mean.
mean, right? Now we are not testing for mean. What we are doing is we are comparing means, right? Same similar actually. I can say testing for comparing the means, right? So in this case, what will be my test statistic? It will be x bar minus y bar or y bar minus x bar, anything, right? So these are the sample means from two populations, right? Correct. And here x bar minus y bar belongs to normal mu1 minus mu2, and what is this here? It is sigma 1 square by n. So it can be n1 plus sigma 2 square by n2 if n1 and n2 are the different number of samples, right, for x and y. Fine. So this belongs to what?
Normal. Sorry.
Normal distribution.
Yeah, normal distribution.
Correct, right?
Yep.
So not normal distribution. Normal distribution with, yeah, it is normal distribution with mean equal to mu1 minus mu2 and uh, variance equal to
Variance
sigma
equal
1
to
square
this.
by n1 plus sigma 2 square by n2. And again, now this you can convert it into z, right? How to convert it? Previously we used to convert like this. Here how to convert this into x bar minus y bar into this is, you can say mu1 equal to mu2, because in this case my null hypothesis will be what? Mu1
Mu is
1
equal to
equal to
mu.
mu2. So
Yeah, yeah.
let's say I can say mu x equal to mu y, right? You can understand, right? Mu1 equal to mu2 is belongs to this. So let's say mu1 is belongs to this and mu2 is belongs to this. So if I say the means of the two samples are same, then this becomes what? 0, right? Mean equal to 0, correct? And
Yes.
alternative hypothesis will be, there can be three alternative sorry, one only one, right? Here mu1 is, oh, three also we can have, right? Yeah, I think we can have. So mu1 is not equal to mu2, mu1 is greater than mu2, and mu1 is less than mu2. Okay.
Are
We
we
can
covering
have
all
three
three in our
cases here.
course?
But I think we are using only this, right? We can use, right, three cases also.
Yes. Theoretical
Yeah.
is we can use, but in our case, I think we are using only mu1 not
We
equal
are
to
using
mu2,
this,
right?
yeah,
Yes.
because what will then happen is we can just convert it like this can be come like this, right? This the format will be simpler than mod of TV, or I can say mod of x bar minus y bar is greater than c. Directly you can use this thing. Okay, not let's not confuse these things. So okay, fine. This is my null and alternative hypothesis in this case. Okay. Now next one is what?
T test.
F test,
Oh, F. Okay.
right? Two sample F test. So F test is what for? It is
Comparing
comparing
variance.
variances, right? So what is this F test? So in this case, what is known and what is unknown? Okay, previously, sorry, we didn't discuss this, right? Here, what was unknown? Means are unknown, right?
Yeah.
Population means are unknown, right? And variance were known, correct? This same thing in one sample test also, right? We didn't know mean,
Mean.
know the variance, right? In two samples test, what happens? We don't know mean, but we know the variances. Okay, this is similar, right? Okay, maybe I can remove. You guys are able to understand this?
Yeah.
Right, huh? Okay. Okay. Please say this if you understand. Otherwise, I will try to explain in other words.
Said that it will be useful for us.
What happened?
Two variable G test, we know variance, we don't know mean, right?
Yeah, because we are comparing for mean. So our test is for mean. So definitely we don't know the population mean, right? That's why we are comparing for the means, right? And in this case, variance was known. In F test, what happens? We are going to compare variances, right? And what we know here. So here we are going to compare for
Mean
variances.
and variance.
Mean we know, and sample variance we know in this case, right? But okay, generally we don't. Okay, so this test will be, I think this test is like this, right? Sx square by sy square. I think this belongs to the distribution f, right? Maybe this is
F of
Sir,
m1 minus 1.
I have a doubt. Can I ask?
yeah, please. First of all, this is correct.
Sir, basically, uh, uh, um, basic. Hello, am I audible?
Yes.
Uh, uh, Basically, I previously learned hypothesis testing, but in graded assignment I need a different value. Like you told that in exam we will give IITM will provide means f inverse minus 0.95 related means value z value or t value. But I cannot able to solve using this value. If in this F test question, I did some other. I use some another method. So if you provide whole T table, chi table, and F table, so it's very good. Otherwise, I don't able to solve this question. Because in
Other
this
method means like I don't
in
understand. But the numbers will
yes,
be same, right?
other method like no means in like a graded assignment third or fourth question, f inverse 0.95 is equal to something. So I need f
Okay,
0.05 value in f table. So that's why
which question you are talking about?
In third question, they given mu
no
and
12th graded assignment 12th means z and z test, and I think z is I yes, which one we are third one, yeah. So I need f 0.01 value, so significance level is 0.01. So that's why
See, okay,
I cannot
significant.
able to
Right. Okay, one more thing. So it is 0.99, right? So 1 minus f inverse of
no, uh, no, you are perfectly right because using Andrewson method, I can able to solve, but I know p value and high confidence intervals method, so I used to this method. So I really face some constraint to transfer. So that's why if you give a full F table, I previously give NPTEL exam, so they provide full F table, G table, and T table. So uh,
Okay, I
It
understand.
really
I
beneficial for
understand,
us.
but
Sir, yeah, sir, please help how to find whatever value he is asking, how to find that with the help of given information.
no, the thing is, how that value comes, and I need to know, right? What I
So
think is,
he is
it,
saying f of 0.01. He is saying f of 0.01.
but why it is needed? That's what I wanted to understand, right? Why it is needed?
Uh,
So,
The question is
because I
asking us,
saw.
can we conclude
one minute, Ganga, sorry.
level of significance?
1 minute. 1 minute.
Yeah.
So, yes. So, okay, you are using some other method to solve this problem. You're saying, right? Do one
Yeah,
thing.
yeah, confidence interval. Yeah.
Okay, fine, fine. I understand. So do one thing. Just write down your solution, and can you post it on the discourse? I will check that, and if it is needed, right?
Yeah, yeah.
Yes.
I already posted twice, I think.
Okay, I'll check. I'll check. So I'll check. See, it's not easy. It's not easy for us to provide that entire table there, because again it will. So see, we have already given the exam paper to the TCS. So it's not like now
Okay,
we,
okay, yeah, yeah.
right? So the thing is, if it
Yeah,
is
yeah.
very needed or it's very required, I will try to convey to the team. If it is possible, we'll be able to do that, because I think we have given the paper already. So it is already in the TCS system. So we'll see. Let's see. But you have already posted the solution, right? Please provide the solution how you solve this question. Then I will check. Okay.
Every question I saw using Z
Okay,
test
okay,
and
fine.
T test. But here, sir, you use alpha method. So
Okay,
yeah, I
okay,
will
we'll see.
post
We'll
it.
see.
No problem.
Just
Thank you so
check it
much. Yeah.
once.
In the same question, I have a query, sir, please.
We are actually okay.
Yeah, in actually there it is given sample variance, na, sir. This 10 and 14, these are standard
Yeah.
deviation of sample, or
Hmm.
it is of population
Sample.
sample, and uh, right, and mu sigma 1 is equal to sigma 2, na? Then
See,
only we
this
cancel the
okay.
narrow.
So the same question is there in this our today's session. So just solve this question and we'll see the solution there. Okay.
Right, right.
So okay, we'll start anyway. We're like 40 minutes late to start the session, but I think it was needed. So yeah.
Sir, a small thing to your kind
Hmm.
notice, sir.
Hmm.
Actually, for extra marks and activity kind of thing,
Hmm.
we got some mail kind of thing. Can
Yeah,
you
yes.
explain regarding that one,
Yeah,
please?
seven extra activity. So previously, those students who haven't submitted the four activities out of six, right? They have a chance that they can submit this extra activity, and we actually this is not going to be peer review method, since it is like very last time, last minute extra activity. So we are going to check by ourselves. So if it is good, then we'll give the marks. Otherwise, it will be like 0 marks will be considered directly to that activity. Okay.
Yes,
Uh,
sir. Yes, sir.
uh,
One more thing. Can we have a general direction how to go for that one, sir?
okay, so this extra activity is related to, so what you have to do. So I think we have given the sample example also, but I will try to tell you how to do this. So you have to first of all find a newspaper article which is related to some data. Okay.
Sir, that sample article is not able to really open
No,
it because
no,
it is demanding a subscription to Hindu.
no, sir. It's like free, right? You can actually have
No,
like
sir. Hindi is having some restrictions kind of thing.
What?
what is
Yeah,
that?
Hindu is always having some restrictions.
Yeah, but I think 2 to 3 are free, right? 2 to 3
No,
articles per
no,
day
no,
are
no.
free.
The case what they are referring is only one is there. That is ultimately is demanding to subscribe to see that one.
So you can check other papers also. I think Indian Express also will have. So generally, what happens is every paper will have the one section related to some. So for example, missiles, Russian missiles. So Russian missiles. So not Russian missiles. How we are importing the like missiles or guns from other countries. So general perspective of ours is we are going to purchase it from Russia mostly, right? But it's not like that. We are going to purchase it from other countries also more than Russia. So you can check if you know the topics. You can check from. It's not like needed to go only for Hindu. You can go for other newspaper also.
No. To see the sample what it's already given
Huh.
and understand the
You guys
method
are
how
not
it is
able
being
to.
applied,
Huh.
we wanted to see that example,
Huh.
and that example is not able to be seen.
Is
All
it?
because it is demanding a subscription. So if you can give that example related to some other newspaper which does not demand subscription, then at least we can understand it.
But I think if you click on that, you will be able to open it, right? For the
No,
first.
sir. You are having IITM subscription, so it will open for you. But for us, or the normal people, it will not open, sir.
It will not open.
Okay, so can you check? Okay, maybe I'll check once.
So
Yeah,
can
you
somebody
know.
please make a PDF of it and post it on Discord? I mean, that will get done, right?
Anybody who is already having an online subscription, probably they can see it.
So okay, one minute, 1 minute. What is, can you check? I think this is related to some grandmaster thing, right? I don't know.
So if you open the email, it takes you down all the way down. No? Sir, why don't you try with that email?
Which email? My email.
No, the email sent from IIT Madras to
Yeah,
all.
that is sent to sir.
Yeah, that will take you down all the way to the article.
But it's opening in mine actually. It's not like. Okay.
You might
Obviously,
have subscribed.
you got
No, I do not have
authorities.
subscription for
Yeah,
this.
from IITM actually, you'll be having that one, sir. That is default. IIT Madras and Hindu are old enough in Chennai.
So maybe I'll check in my other email ID.
Want we can forward you that one.
I think some person is already able to see this. I'll check. Fine.
It's opening everywhere.
It's opening, right? That's what I'm
Yes,
thinking.
sir.
It's not like it's. See, I think for Hindu also per day 3 articles or something is there is a limit or something. I think. But okay, let's see. Yeah, it's opening. See, without in incognito mode, if I'm using it right, this link it's opening. See, this is not at all. See, you are able to see any. I'm not using the. I'm using the incognito mode. I just pasted this link here. It's opening. I don't know how it's not opening for yours.
No, I will send you the link.
Why you're sending me the link? The same link is there, na?
No. You may have to go to fourth document to get the.
Check this link. Okay, I'm pasting this link in this, and you can open it incognito. Is it opening or not?
Incognito.
See, incognito you need not require any sign in, right? So without sign in, also try to open it. I think it's opening.
See here now. Can I send you the link and give it a try now?
Which? Okay, in chat box I have sent one link.
Yeah, I will just send you in the chat box.
Okay.
I have printed it in PDF form. I will just post in discourse. Or I will say just drive. Okay.
Yeah, thanks. Okay, just do this because I
Thank you,
think
sir.
wasting this time in this.
Okay. Yeah, please carry on.
We'll see at the end of the session, right? Anyway, we are like very late for starting the session, so.
Yeah, I just fixed the link. If you can try this one.
No, I'll check at the end of the session. We'll start the session first, and I think because we are getting very late for this,
Okay.
we'll finish the session first, and then we'll think about this. I think it's opening, but let's see. Okay, so the usual thing, please join the joinpd.com by using this code here, which is KTFTNK. Okay, so use the joinpd.com on your any browser and just use this link, use this code there, KTFTNK. Okay. KTF, TNK. I'm seeing 9 students are connected. Others also, please join this. So this is our first question. Okay, we have introduced one format. I think it is there in week 11 also. This is kind of multiple choice question format, right? MCQ type. There are like for one question there are 12 or 13 options are available, and you have to choose which are the correct options. Correct. So I'm going to try this format here also in question 1. So see, these are the some options. For that you have to tell which are the correct options. So first of all, try to give the answer for this question, and the same question we are going to try for uh, this MSQ type of thing. This is called as EMQ, which is extended matching questions. Okay. Now the question 1 is, in the past the standard deviation of weights of salt packages filled by a machine was 40. Okay. To decrease the standard deviation of weights, a new machine is introduced. A random sample of 25 packages from the new machine showed a standard deviation of 32. Based on this data, what is your conclusion at a significance level of 0.05 on the standard deviation of weights of salt packages filled by the new machine? So are you able to identify which kind of distributions are we going to use for this type of problem? So we know what? We know sample standard deviation, right? So, okay, first of all, which test are we going for this?
I
Are we
square.
going for, okay, that test, okay, the standard method test, that not that test. Are we going for testing for means or testing for standard deviations?
Once again, please.
Okay, so what I'm saying is, this problem is there. This
Yeah.
problem is for testing a mean or testing a variance.
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 We're trying to reduce the variance, so it's
testing. Yeah. So if it is testing for variance, and it is one sample test or two sample test?
two samples.
One sample test, right?
No,
We are
two.
comparing two samples, right? It's only one sample, correct? Why two?
Okay, sorry.
Correct,
One
one
sample,
only.
but two machines. Okay.
That's all. So that means it's one sample test, and we are testing for variance. So we know for one sample test, only three tests are there. One is Z test, T test, and chi-square test. So Z test and T test are for testing for means, right?
Means.
And chi-square test is for testing for
Variance.
variance. So now we are going to use which test? Chi-square test. So anyway, this is given here. Use f chi-square 24 something. Is from there you are able to understand. But in the exam, this this thing is not given at under the question, right? This value is given in the top. So by looking at the question itself, you will be able to identify which tests are you going for. So that's why I'm emphasizing on this, that just reading the question, are you able to find which tests are we going to use? Okay. So
Yeah.
there are two options to solve this. One is standard deviation of weights is 40 and standard deviation of weight is less than 40. So that means it's a test. Okay. Which test are you going to use?
It's a chi-square.
Okay. So chi-square test, and okay, try to find it answer. Option A is correct or option B is correct. Okay, just take 5 to 7. How much time you will take for this? 10 minutes? 5 minutes? Let's take 5 minutes from there and we'll see the solution. Because we have to see the AMQ part of the solution. Let's take 5 minutes. Okay, only one response I'm seeing here. Why? It's taking time or what? So this is the same thing which we have done for z-test. So here what we are doing, sigma equal to, so what is my null hypothesis here?
Sigma is equal to 40.
Sigma equal to 40. Okay. What is my alternative hypothesis here?
Less than 40.
Less than 40. Okay. So, and what is my test? Chi-square is n minus 1?
20.
Huh?
N minus 1
S square by?
S square by
Sigma square, right?
Sigma square, yeah.
What is S here?
40.
S. Sample. S is what? Sample mean, right?
Yes, sample. Sample
32.
Sorry, not sample means sample standard deviation is 32, right?
32.
And what is sigma? 40. So n is what? Number of samples. So n minus 1 is 24. So my test will be 24 times S square by sigma square, right?
If you are writing, we are unable to see, sir.
No, I'm not writing. I'm just you guys have to solve, right? Once you solve, we'll discuss that. Then I'll write. I'm just giving you the that. Okay. Okay. Shall I tell you like how to go or how to solve this? Because
Yes, sir. Now I think we can start now.
huh?
Yes, sir. We can proceed with that.
No, only 4 people I think give their response. So I'm just thinking like what's the problem? If you can tell me what is the problem, maybe I'll write it down.
I think C square or C, I have a confusion.
You can take anything, c square also, c also. Then you have to anyway you have to make the square, right? Because what I told you is that n minus 1 s square upon sigma square. This is a chi-square distribution. So you have to anyway make that into that format, right? N minus 1 s square upon. So general test is what? Probability that s is greater than c given that h naught is true. So if you start with s is greater than c, still you have to multiply and make a square. Okay, maybe I'll try. I'll show you once. So this is the format, right? Where is that? This one, right? N minus 1 s square by sigma square, it belongs to chi-square distribution. So what is my test here? Alpha. So alpha is equal to what? Probability that s is less than c, right? This is given that h naught is true. This is the question, right?
Yeah.
So that means probability I'll write is s is so.
We write null and alternate also.
From the initial you wanted to solve it, huh? Okay. Fine. You just guide me there, all the values and that thing tell me, okay? So my null will be what? Sigma equal to 40, right?
40, yes.
Or sigma naught. And alternative hypothesis will be sigma is
32.
Less than 40.
Okay.
I can say 32, right? Because this new machine is introduced, so that means sigma is less than 40. So this is anyway left tail test, right?
Okay, got it.
Huh?
Okay, sir.
Okay. Then my alpha is what? Reject h naught, given that h naught is true. So which means probability that s is less than c, given that h naught is true. So h naught is true means what? Probability that s is less than c, sigma equal to 40, right? Now, what I'll do here, I know that my chi-square distribution is what? It should be like this, right? S square upon sigma square into n minus 1, right? This is my distribution, chi-square distribution, right? Correct. I have to make this into that format. So how I'll do this? I'll first make square, a square, c square, right? Divided by sigma square. I'll do sigma square here into n minus 1 into n minus 1. So I'm doing it on the both side, right?
Yes.
Okay, this is okay.
Yes.
And this is what? Chi-square. Chi-square n minus 1. So n is what? In this case, n equal to 25.
25.
So I'll say 25 minus 1 is 24 is less than c square. What is sigma square here? 40, right? Because
40 to 40.
I said given that 40 sigma equal to 40 into 24, right? So this is so okay. I should not write now this thing. Okay. Okay, that is okay. That is okay. Probability. So let's say then probability that chi square 24 is less than 24 by 40 square into c square, and this is nothing but what? F. This is a you know, right? This is CDF. So CDF. So CDF of chi square is what? F chi square 24 of what? So this will be 1 minus or only f chi square?
Only.
Only, right?
But it is less than. It is less than.
Yeah. Just think of this curve only. So f of all these things towards the left, right? So f chi square 24 by 40 square into c square, which is equal to what? Alpha.
0.05.
And alpha here it is
0.05.
0.05. Now what next step is f inverse, right? F inverse, so yeah, like this of 0.05 equal to what? 24 by 40 square into c square. So again then you can solve it. C square equal to what? 40 square by 24 into f, and you can solve, you can check what is the value of c square, and then you can say that
923.33.
and then you'll compare with what?
Sigma. 40.
32 square.
32 square.
32 square, right? You're comparing
This
for
1024.
Yes,
yeah,
sir. We will compare 32. Sorry, we'll compare
32 square,
32.
right?
Yes, sorry. Yes, sorry.
And if it is
1024 is higher than
higher,
923.
then what is the, so are you
Except
going to
H
reject
naught.
or accept it?
Except
So accept x naught means A and B is what?
Option A.
A.
Option
A.
A.
Option A, right?
Option A.
Okay.
Yes.
This is okay. See, this is the same thing we did for Z test.
In also. In.
It's not different, right? It is only different thing is what we are testing for. That's it. Whatever we are doing, the same is for Z test and T test, chi-square test. Everything the format is same. Okay. Okay. Now tell me. Okay, this is I don't know. Like 6 people have responded. So anyone wants to give the answers now? It's already given the answer. Okay, fine. For this question, please can you tell me which are the correct steps among 1 to 13? Just write it down in that text box which is shown for this question there. So let's say 1, 3, 7, 9 are the correct answers. Then 1 comma 2 comma, sorry, 1 comma 3 comma 4 comma something like this. Just do that. Okay, so 10 students have already responded out of 18. Okay, uh, so this is not different than what we did, right? First of all, tell me null hypothesis is what? Sigma is less than 40 or sigma equal to 40?
Equal to 40.
Equal to 40.
So option 2 is correct. Okay.
Yep.
So okay, divide this 13 into this steps. Okay. So first step will be finding null hypothesis. Okay. What is the alternative hypothesis for this?
Less than 40.
Less than
Less than 40.
less than 40. So if it is less than 40, then which test we are going to use? Right tail,
Left.
two tail, left tail.
Left tail.
So out of 3, 4, and 5, which option is correct?
Fourth one.
Fourth one is correct. You are understanding right now, right? So first two steps are for null hypothesis. Third, fourth, and fifth option is for the second step, which is alternative hypothesis. So if you are able to identify the correct alternative hypothesis, then we can able to choose one of the options out of 3, 4, and 5, right? Okay. Now this test is for what? Is it a one sample test or two sample test?
One sample.
One sample test. So which are the one sample tests available?
Chi-square.
No. Which are the one sample tests available generally?
Chi-square?
Z test and chi.
Chi-square. So we are using here chi-square because
it's
Variance is
variance. So out of three, so 6, 7, and 8 option, eighth option is gone because it is two sample. It is not two sample test, so it is wrong. Okay. T test we are not going to use because we are not comparing means here. We are comparing for, so no, we are testing for variance, not testing for mean. So option 6 is gone. So which option is remained there? Option 7. So chi-square test is used. Now, which of the test statistic we are using? Sample mean, sample variance, or population?
Sample variance.
Sample variance. So option 10 is correct. Now the solving part is we are going to accept H0 at 0.05 or we are going to reject H0 at 0.05. So that question's answer is from the previous problem solving, right? So here you chose option A as correct. So option A is correct. That means we are going to accept the H0. So option 12 will be correct. So which are the correct options among these 13?
2, 4, 7, 10, and 12.
2, 4, 7, 10, and 12. 2, 4, 7, and 12. So the correct options are 2, 4, 7, and 12. 10 also is there?
Yeah. 10 is the.
Yes,
sorry.
sir.
Yeah, 2, 4, 7, 10, and 12. So those who are given 2, 4, 7, 10, and 12, you will get all the marks. Those who are given only 2, 4, 7, 10, or 2, 4, 7, 12, they will get partial marks. So this kind of question will be asked in the exam also, okay, in the quiz end up. So that's what I'm just emphasizing on this, how to answer this type of questions. So the partial marking will be also there, but if you give any wrong option, then you will get 0 marks. So this is same kind of MSQ, right? Multiple select questions.
That is bad, sir.
But see, the thing is that is bad, it's okay, but it's like you will be able to find the steps, right? If you are correct in steps itself, you will be able to answer the final answer properly, right? This is actually helping you, right? See, if you have given this kind of format of question, and if you do the wrong calculation, you'll get 0 marks. Instead, if you give the correct options here, you'll get some marks, right? Even though your calculations are wrong. Correct?
True.
Okay, so we'll go for
This time you are going to ask the steps.
Huh?
Are you going to have separate marks for steps?
Yeah, for one question.
End term, do you really?
Yes.
Oh, okay.
Okay. So we should not.
Could not get 1 point, so just it will take less than 30 seconds. Like generally in multiple selection type, what happens? say for example, four options are right? And even if I have ticked all my three options are correct, but if I have ticked one option wrong, so entire marks get deducted. So are you going to change that method or what this time?
No, this will also be same.
Okay.
Okay, got it.
Okay.
So better choose the right one, couple of right ones.
Yes,
Yeah.
yes,
If
no
you are
problem.
not confident on any other option, right, don't choose. That's all. Okay. Okay. So, okay, shall we proceed to the second question directly, because we have already discussed the solution for this, right?
Yes.
Okay. So I am
Please go to
skipping the
second.
solution. You can
Yes,
check it
let us
later
go to
on.
second.
Okay. This is the second question. A sociologist focusing on popular culture and media believes that the average number of hours per week spent on social media is different for men and women. The researcher knows that the standard deviations of amount of time spent on social media are 8 hours per week and 10 hours per week for men and women. Examining two independent random samples of 100 individuals each, if the average number of hours per week spent on social media for the sample of men is 3 hours greater than that for the sample of women, what conclusion can be made for the hypothesis? So here what we are doing, what is given us, we have the population standard deviation as well as population standard deviation for two different populations, right?
Men and women.
Right. So men is one population, another population is woman. What we are doing here, we are comparing the means of two populations, correct? So consider one population as men, another population as woman. We are comparing the populations of or mean of the populations, two different populations, right?
Yeah.
Okay, and they have different variances or
Variance.
standard deviations, right? We are checking for if the sample mean for men is greater than the sample mean of women, right? So our null hypothesis is what?
It's the same.
Greater than
Null hypothesis. See, null hypothesis should be simple, so it will be sample mean of one population equal to sample mean of other population. In other words, it will be mu1 equal to mu2, right?
That's what I'm
And alternative hypothesis will be mu1 is not equal to mu2. Okay.
It's already given there, is what I was saying.
already given, sir.
It is given there. Yeah, but I'm just telling you that
Okay.
if it is
How to
not
assess?
given, then how to
assess? Okay.
Yeah. Okay. So just try to solve this. This is just again Z test, but it is two sample Z test. Right? Why two sample Z test? Because two different populations we are comparing. We are comparing here. Yes. Right? Okay.
start, sir. Let us start.
Okay, so I think 11 responses are there. Okay. 5 are saying reject H naught, and 6 are saying, 7 are saying accept H naught. Okay. Huh? Numbers are changing. Why? Okay. Okay. So shall we see the solution now?
Yes, sir.
Okay. So first of all, what is the test statistic here? X bar minus y bar, right? Is equal to 3.
Yes.
Correct. Correct. Now, and x1 and x1, x2 to x100 belongs to a normal distribution with unknown mean mu1 and sigma square, which is equal to 8 square, right? Y1, y2, y100 belongs to a normal distribution with unknown mean mu2 and known variance 10 square. Okay, the next step will be this, which is given, right? Another hypothesis is mu1 equal to mu2. Alternative hypothesis is equal to mu1 is not equal to mu2. So our test is x bar minus y bar, or test statistic is x bar minus y bar belongs to a normal distribution mu1 minus mu2, and variance is 64 by 100 plus 100 by 100. So you understand, right, what is happening here? The sigma square by n1 plus sigma 2 square by n2, right? But here in this case n1 and n2 are same, so 100 and so same is n1 equal to n2 equal to 100. So it belongs to normal distribution mu1 minus mu2 164 by 100. Okay, and our test is reject h naught if mod of t, that means mod of x bar minus y bar is greater than c, right? This fine, right? You are able to identify, right? Because see, here the sentence is if the average number of hours per week spent on social media for the sample of men is 3 hours greater than that of sample of women, right?
Yes, sir.
Okay, so now alpha is probability that mod t is greater than c given that h naught is true. So this is t divided by root of 160 by 164 by 100 greater than c divided by root of 164 divided by 100. So mu1 equal to mu2 is the test, right? So mu1 minus mu2 equal to 0. We are checking for that, right? So mod of z equal to, so mod of z is greater than c divided by 164 by 100, and why it is 2 fz of minus c by 1 root of 164 by 100,
Because it's mod of z and it's greater than,
right?
because of the greater than sign we are doing.
Okay,
And
correct.
mod of z.
Right. So if you take, so we have to find the value of c. So alpha is what? Significance level is 0.04. So 0.05 divided by 2 is 0.025, and we are taking fz inverse of alpha by 2 here. What? Okay, alpha is 0.01. Huh?
It is
Yes,
0.01, sir.
0.01.
0.01.
Okay, fine.
0.01, sir.
Alpha, okay, fine. So 0.01 divided by 2 is 0.005. If you do this calculation, you get value of C as 3.29, and 3.29 is greater than 3. So we'll accept
Null hypothesis.
accept the null hypothesis. So accept null hypothesis is the correct answer.
Option B. Option B.
Only minus
Sir,
c.
just a small doubt. Even I. Yes, yes. Go on. Go on. Okay, you finish the answer.
Yeah, we taken minus c, no, sir. Left side only we considered. Why so actually? If we consider c by root 164 by 100, then it will be less than 3. Minus value will come.
How I don't understand why.
Sir, mod z greater than c by 164 by 100.
Correct.
It can be written as 2 into fz of c by root of 164 by 100 instead of minus c.
No, it will be minus c, right? Because
draw the pictures, and then he can easily understand that point.
I think
forgot
it's
to take
already, I think, okay. Some I forgot actually, but I think in one of the places I did it. Okay, fine. So we have discussed this, right? Once? No.
Yes, sir. I think in one of the sessions.
Yeah.
Yes, sir.
For this, we have taken time. Okay, fine. So this is my 0, 1 normal curve, right? Which is called Z, right? Z curve. Okay. So our test is mod of Z is less than C. So that means what? Less than C or greater than C is this? Greater than, right? Okay. So what does this mean? Go on.
ये z greater than plus or minus c.
So like final, tell me final.
Z greater than c or z less than minus c.
Okay. So Z greater than C is which part? This part?
Yes, yeah.
And Z minus less than minus C is what? Which part?
Right.
This part, right? Okay. So this is C, this is minus C. So, and since it is symmetric, so this portion and this portion, they're equal, right? This area and this area is equal, right?
Yeah, sir, right.
So, and what is fz of C? The entire portion here, right?
Right, sir.
So I cannot write 2 times fg of c. 2 times fg of c means this blue portion 2 times, right? We are interested in this red portion, right? And this red portion is equal to what? 2 times fg of minus c, right? Hello?
Yeah.
This clear, right? Actually, so like this, so you can say that this 2 times fg of minus c. That's why we are taken 2 times fg of minus c. From there, we are getting the value of c as 3.29, and we have already defined test statistic that if 3 is so that c is less than c is greater than 3, then what we'll do? We'll accept, right?
Reject null. If it is greater than, then we will reject. Since it is less, then we will accept. Yes, yes, sir, correct.
Okay, right? So, okay, then.
Sir,
Hmm.
I have a small doubt. Could you please come to question, sir? Sir, though here you are defining null and alternate for us for better understanding, but as you rightly said that in exam it will not be given, right? So, sir, you just let us read the first line. The sociologist believes that the average number of hours per week spent on social media is different for men and women, right? So he is believing that it's different. So my null will be not equal to, right, in that case.
Correct. No, not null.
No, because he believes, no, sir, that's my prior, belief that it does not, they are different. So I believe it's not equal to, since here you are given, then we all solved and we got the right answer. Even I also got the right answer. But while reading this first line, this feeling is coming to my mind. So where I am going wrong? Because this is my prior belief. And my prior belief is always my null, and whatever I am going to prove that becomes part of my alternate. That's why we write greater than or less than or not equal to. A sociologist just read the first line, and media believes that the average number of hours per week spent on social media is different for men and women. Generally, we say no, that my mean is this much, so that becomes my null, and then we choose whether it's a right tail or left tail.
Okay,
This is
so
creating some sort of confusion here, sir.
So okay. In that case, you think about like this. So our null hypothesis generally what will have? Will it be a simple hypothesis or a composite hypothesis?
No, here we are taking a simple only. Here we are taking simple only, sir.
Generally, we'll go for simple, right? So what we can
Yes.
think about is the sociologist. He thinks that this might be a different thing, right?
Yes.
So we can claim that they are equal. Okay, the average number of hours per week spent, they are equal, and that we are saying that to reject this, the sociologist has to do some survey or to do some sampling, right? And he has taken 100 samples each to claim that they are different.
So can we just decide that the researchers' intuitive thinking is always alternative hypothesis?
No, it's not like that actually. Okay.
I mean, it's fundamentally that is the way it is. Right?
See, if
So
you
the researcher
are
is doing something to prove what the common belief is. So that has to be an alternative hypothesis, where the common belief is the null thing. Right? So that way it is equal for men and women. Am I right in my reading?
okay, so generally what when you do survey is to uh, change what is there, the existing claim, right? Existing
Correct.
thing.
Yes, yes.
So here what is existing thing is, let's say the number of hours spent by men and women are equal, and let's say I am a sociologist and my belief is they are different. The number of the average number of hours per week, they are different. To
Okay, you are
check my
saying to
claim,
think from this perspective.
yeah,
Okay.
to check this claim, because this is his belief, right? Sociologist belief. This is not the
This is not the universal belief.
right. So universal thinking or maybe whatever thing is, this is my null hypothesis, right? correct?
Okay. Okay. Yes.
And
Yes.
I am
So
believing,
from that
so
perspective,
yeah, let's say one surveyor will come and he'll say that okay, the number of average number of hours per week are something greater than this for men and women. But then I have to choose what is the null hypothesis. It should be equal, and my to check my claim that if it is not equal, I will do some surveying, correct, or sampling, and then based on that result, I will accept the null hypothesis that they are equal or not. You
okay, sir.
understand, Elliot?
From that perspective, I got it, sir. But
But
we need to
generally,
be
generally,
very careful this kind of tricky question in exams, sir. Because in graded assignment one, sorry, 11, not one, 11, sir.
okay,
There is
we'll
a
see.
question.
We'll see that also. Let's say any question you'll see, and we'll think of like this.
No, no, let us continue. I am not saying to go to 11, sir. I am not
No,
saying
we'll
to
see.
go
No,
there.
no,
Let
no.
us
I think
continue
see
with.
this is important thing to understand. Is it null hypothesis correct or not?
Okay,
Whatever
then
you're
scroll
thinking.
down. Then scroll down slowly,
Yeah.
slowly. Okay. I
Here it
think
is not
this
given,
one
right?
only.
I think.
Where yes, just where there is a proportion test. Yeah, yeah, this one only. I think this one only. Right.
Hmm.
Hello.
Yes, yes. I'm able to.
Yeah, yeah. I think while discussing the class, we said that proportion is also right. So when someone, in fact, not someone, I
Ah.
picked this option,
Hmm.
statistics uses proportion P.
Hmm.
And then the correct answer came as all my other options are correct, but it came that no, test statistics uses sample make. When we did, when I highlighted this to Nikita ma'am, then she said okay, we will take care like this. So when this kind of perspective difference kind of question comes, then it will
Okay,
create problem.
regarding this, you are saying yes, statistic is
Yes, yes,
proportional
yes.
behind the statistic. Okay, fine, fine. That is okay. That is I understand. That is understandable in this case. Maybe we can make the
And
changes
similarly,
in
there
this.
is a question related to 0.36 and 36. That also, madam clarified. We have taken
Okay.
care of that.
Okay.
But what
Okay.
I'm
So
saying, even this kind of perspective difference comes into picture, and it's an intern
see,
exam.
so no, exams and that will be like very carefully designed. See, the thing is,
Okay, okay, sir. We can
it's
proceed,
not
sir.
like
Yes.
so here in the grade assignments or somewhere, right, we'll try to see like what can be the what kind of problems students can face, right? So that in that way we are thinking. So we'll try it, and if some problems students are facing, accordingly we'll change, right? But in the exams, we'll already be considered like
Okay, sir.
there should not be any confusion because it's an exam, right? So in case exam, if any confusion occurs, you don't have time to change, right? So mostly exams will design it carefully. Okay. Okay. So shall we move to the third question?
Yes, sir. Yes, yes.
Okay. I think third is okay. The manufacturer of a new car claims that okay. Here we'll think about what is the null and alternate. Okay. The manufacturer of a new car claims that a typical car gets a mileage of 36 kilometer per liter. Okay. We think that the mileage is less. Test or suspicion, we perform the hypothesis test with h0 mu equal to 36 and ha mu is less than 36. So here why we are saying that mu equal to 36, not less than 36? This is the hypothesis. So this claim is different from the other claim, right? So, uh, so this
Here is
manufacturer,
very clear. Here
okay.
is very clear that
So no, it's why it is clear because the manufacturer claims that means the manufacturer having a lot of experience in manufacturing the
correct. Yes,
right,
yes,
and there he has
yes, yes.
said that this the mean is equal to 36, correct? And now I think that the mileage is less. What happened in the previous case? A sociologist believes, right? That means he thinks like that. The average number is different, right?
I got that perspective, sir. You are saying that universal belief is
Yeah.
that they are same, and that
Huh.
researchers believe that no, it's different. So from that
Because
point of view, I
researcher
got.
can be me and you, right?
Yeah, yeah, yes, yes, yes.
Right. But some there is no evidence for that, correct?
Correct,
Like in
correct.
this case, the manufacturer have the vast experience in doing
Uh,
this, and he is saying that
so
this
many
is equal to
data,
this.
past data to support that. Yes.
Yeah. And if I wanted to change that belief, what I'll do is I'll just do the sampling, right? I'll just collect some samples and I will do the test on this samples, and accordingly will reject and accept the null hypothesis, right? Okay. So suppose we take a random sample of 100 new cars and find that their average mileage is 36.4 kilometers per liter and the sample standard deviation is 4. what does a t-test say about a null hypothesis? Okay, anyway here it is given the t-test, but if it is not given t-test, then how can we say that it's not z-test and it's t-test?
The population standard deviation is missing, sir.
Correct.
Population
So
standard deviation is missing.
so yeah, population standard deviation or population variance is unknown. So that's what, right? Okay, fine. So this will be, I think it's easy. So just take 5 minutes to solve this and we'll discuss the solution.
Sir, are you there?
Okay. 8 out of 10, 18. Shall we see the solution then?
Yes, please.
Yes, sir.
6 people, 7 accepted, 3 rejected. Okay. Check. Sorry. So we already given alpha equal to 0.05, sample mean equal to 36.8. Now the hypothesis given as mu equal to 36. Alternate is mu is less than 36. Okay. Our test is reject H naught if X bar is less than C. So test statistic used here is sample mean, right? Okay. So first of all, how to convert this X bar into T test? Sorry, T distribution. How will you convert X bar into this T distribution? So X bar less than C. What operations you have to
Subtract 2
perform?
divided by S by root 2.
X bar minus
The
mu
root n.
divided by S by root n, right? Because sigma is unknown here. We have given the sample variance, I think, given, right? Sample standard deviation. Yeah. Right. So yeah. In this problem, we know the the population variance. So we don't know the population variance. We know the sample variance. Alpha is equal to probability that X bar is less than C, given that mu equal to 36. So X bar minus mu is 36, right? Divided by root of S square by n, or S by divided by S by root n, right? And same operations will perform on the right side. So it will be C minus 36 divided by root of S square by n. So this is what? This is T distribution, right? It belongs to T distribution. So it will be, and why it is 99? N minus 1. So n is 100 here, right? So T 99 of C minus 36 divided by root of 16 by 100. So root of 16 by 100 is nothing but what? 4 by 10. So this will be C minus 36 divided by 4 into 10, and this FT 99. So if you'll take this step, should I write it down or it's fine for you? You're able to understand, right?
Yes, sir.
How this happening? All of you? If any doubt is there, I'll maybe I can solve also. Okay. If you I won't show it directly, I can solve also.
I got it.
Got it,
It's
right?
clear, sir. It's clear, sir.
Okay. So FT 99 inverse of 0.05. So this will be here. Then root of 16 by 100 it will come here. So it will be 4 by 10 and plus 36. So it will be C. So C equal to 35.336. Now we said that X bar, our test was what? If X bar is less than C, we'll reject H naught, right? So C is 35.336. Is it greater than X bar or less than X bar? Is less than X bar, right? So
Yeah.
we'll accept H naught. Is clear? All of you are understanding how when to accept and when to reject, right?
Yep.
Yes, sir.
Okay. Okay. So we'll move to the last question. So this an IITM instructor conducts 2 live sessions for 2 different classes. Call it A and B in statistics. Session A had 25 students attending, while session B had 50 students. Okay, the instructor conducted a test for the 2 sessions. Although there was no significant difference in mean grades, session A had a standard deviation of 12, session B had a standard deviation of 15. Can we conclude at the 0.05 significance level that the variability in marks of class B is greater than that of class A? So which test are we going to use here?
F test.
YF test?
Two sample standard deviation comparison.
Because it says
Comparison.
Variance
of
comparison.
F.
Yeah. We are going to compare the standard deviation of two different populations, right? And it's a two sample test. That's why it is a two sample test, right? We are taking two samples from different populations, A and B. Okay. And we are comparing the variances, right? And what is given there? Mu1 equal to mu2. That doesn't matter actually. Okay, fine. Okay, please solve this. Take 5 to 7 minutes and we'll discuss the solution. Okay, so is it done? Hello? All of you left.
Yes, sir, done.
7 are saying no and 4 are saying yes. The question was, can we conclude it's that the variability mass is greater than that of P? So if you're saying yes, that means, okay, what was your null hypothesis in this case?
Both are same. Sigma equal to sigma b.
Sigma 1 equal to sigma 2. Okay, or sigma equal to sigma b. And what is your alternative hypothesis there?
Not equal to.
So
Yes.
answer is accept H0, but I don't know what to give, yes or no.
Yes or no?
No, if answer is accepted, then no, no.
Okay, so we'll see the solution. Okay, then we'll discuss. Shall we discuss the solution then? That
Yes,
is
please.
okay. Whatever the answer is fine. We'll say. Okay. So H naught was equal to sigma 1 equal to sigma naught, sigma 2. HA is equals to sigma 1 is less than sigma 2. So we'll reject H naught if SB square upon SA square is greater than 1 plus CR. Right? And we know that SB square upon SA square is what? It belongs to the F distribution with degrees of freedom n2 minus 1 and n1 minus 1. Okay. So n1 is equals to what? Number of samples for A, right? Is 25. And n2 is equals to what? Number of sample equals to 50. So SB square upon SA square, that distribution is F distribution with 49 and 24 degrees of freedom, right? Okay. Now we'll go for test statistic. T is SB square upon SA square. Test is and the test statistic belongs to F distribution 49 with 49 24. That's so alpha is what? Probability that reject H naught given that H naught is true. So when we are going to reject H naught, when T is greater than 1 plus CR, right?
Yes, sir.
Given that sigma 1 equal to sigma 2. So we can write this as 1 minus probability that T is less than 1 plus CR.
Sir, one query over here. Why it's
Yeah.
alpha? It should be alpha by 2, no?
Which one? Yeah,
It should be
should be.
alpha by
Yeah,
2.
yeah, it should be alpha by 2. Yes, it should be alpha by 2. I think when the calculations are made, it is taken as alpha by 2 itself, I guess. That is correct. It should take alpha by 2, not alpha, because we are saying CR, right? When we are going for this 1 plus CR or 1 minus CL, in that case, it should be alpha by 2. That is correct.
No, but in value alpha by 2 is not given, sir.
So
Value of alpha is given, na, so we can calculate alpha by 2.
calculate
Value
na
of
alpha
alpha
by
is
2.
given. Yes, sir. Yes, sir.
Correct, right?
I'm saying
But I think
I'm saying F inverse. F inverse, whatever is given, you just come to question. It is given for, I think, yes, it is for 0.05.
0.95 it is given.
Yes, it is not given for considering point alpha by 2.
But why would we actually make it twice? It's not
twice,
equal
half,
to it.
half.
What happened?
Sorry, why is it half?
Why is it
Half.
Alpha by 2.
We are going to take alpha by 2, right? Not alpha, because we are just considering one side of this. So I think professor has already mentioned, right? Andrew sir has already mentioned.
Professor has mentioned, sir. Yes, sir. It should be alpha by 2. But in question, the value of alpha is given.
Yeah, correct. So maybe I need to check once, like whether this is correct or not. Okay, but when we are using that SP square upon S square is greater than 1 plus CR. Okay, when we are considering this 1 plus CR, yes, I think we should take the values of alpha by 2, not alpha. Okay, so okay, how does you have done the calculation for this, right? FF
Yes,
inverse
sir.
of 1 minus alpha. What it is giving?
I am getting the value as 1.86. The final value, 1 plus CR value. I think, though it's the same. I think ultimately, so we are calculating 0.95, na? So that's right. So ultimately, it is coming as 0.9. It was for me, it was coming as 0.975, approximately equal to 0.95. F inverse value.
1
That
minus
will not go.
so no, f inverse of what you have taken. I'm sorry.
If
Alpha
inverse
what
of 0.975 I was getting, but I don't have 975 value, so I have taken 95 value.
Okay.
0.95
Okay, that
value.
means it is not given. Then it is like this, right? Okay, but I just.
But the answer is 1.86. I'm getting because ultimately we are considering 0.95.
No, if you are using this value, then you'll get 1.86 only, right?
Yeah, right. But it should be alpha by 2, no? I mean,
it should be alpha by 2. I think.
And 1 minus 0.025 will be 0.975.
Yeah, 0.975. But when we use 0.975, right?
It will be different value.
It should be a different value.
Yeah.
So okay. But you understand, right? How to solve this? I will check with this and I will post it in the discourse. The answer.
So just one small clarification, sir. Like f of 4924 will be same as f of 2449, right?
F of
there are 2 degrees of freedom, na? N minus 1 and N minus 1, right?
But then it will be left tail test. Then it will be 1 plus CR. It will be 1 minus CL.
Yeah,
that's
I
fine.
think so.
I have done in both ways, getting the same answer.
No, you get the same
value.
answer. Yeah.
But just I'm asking you 49, 24, 24, 49 doesn't.
So how can we get same answer? Because CR is not equal to CL, no?
So it will be
it should not
be
CL. So see,
you calculate 1 minus CL, you are going to get CL 1.86 only.
Okay, because it is symmetric. That's why maybe okay.
Yeah, but take this particular value. But take
1 minus CL and 1 plus CR should be equal. Okay, got it.
Yes.
It should not be equal, but the thing, it's not symmetric. The F distribution is not symmetric. That's why we are using that 1 plus CL and 1 plus CL and CR are not same, but with left tail test also we'll get the same answer. The only thing is this SB square upon SS square, right? This will be S square by SB square, but the test will be then less than 1.
Yeah, 1 minus CL.
So test will be different, and
1 minus CL. Yes.
You will use that
1 minus CL.
So you are not going to use this 1 minus probability. It will be directly 1 minus CL equal to this one.
No, sir. It will be alpha only. Alpha equal to probability of T is less than 1 minus CL. It will be.
Then 1 minus CL.
Right.
Yes, TL will be 1 minus CL. Yes.
But you just be careful with this, right? Okay, that ratio will be S square upon SB square there. Then it will be something different, right? Other, if you use SB square upon S square, then it is right tail test only. Right?
I think, sir, in last session, sir, sir had given us a very good thumb rule that whenever we are taking the ratio, right?
It should be
if it is greater than 1. If it is greater than 1, then we have to take 1 plus CR. If it is less than 1 minus CR.
Take CR. Yeah, but what I'll suggest you is when you're finding this, right, just go for greater than 1. Greater than 1, right? It will be like you will get always correct answer. In the left tail test, sometimes it is very difficult to solve that problem. So just go for the greater than 1. So
okay, sir.
You understand, right? Greater than 1 means
where
the higher is there, you can use that thing.
2 minus 1 after N1
minus. So N2 minus 1 and N1 minus 1 we have used here because that SB square value is greater than S square. Okay, with these values, right, that alpha value, I'll just make the clarification on this question. Okay, I'll just go back and once I'll check with this.
I have a question here again. When you said make it greater than, F distribution as such is not symmetric. So
yeah, it is not symmetric.
So if we make it, if a problem is less than, we can't make it greater than, is it?
Yeah. So how can we make this greater than? Just take the, let's say your sigma 1 was, in this case sigma A was lesser than sigma B, right? It was
yes, 12 and sigma B is 15.
So consider this, if sigma A was 15 and sigma B was 12. In that case, how will you make greater than? S square upon SB square, right? Reverse ratio.
Oh, okay.
That's it. Greater than 1 means what? Whichever the higher value is there, is take it into numerator. That's it.
Oh, okay. Okay.
And accordingly, you are that N1 minus 1 and N2 minus 1 will interchange. That's it.
Okay.
Okay.
But those values will be should be provided, right?
Provided, yeah, it will be provided. So that's what I'm trying to do is I will just make sure that how the solution will be with both the sides, 1 minus CR and 1 minus CR, 1 plus CR, right? I'll just make.
Can we derive if it is given inverse like 2449? Can we get 4924?
Yeah, that's what I will try to figure it out, like if which values is provided. So suppose it's already provided here 4924, right, in the problem, then you have to go with this only, SB square upon SS square, correct?
Yeah,
they're not going for 2449, right? That's what I'll just confirm that 2449 value how can we use, and if it is given only 4924 in the exam, then what you are forced to do is SB square upon SS square, right? Because this is 50 minus 1 and this is 25 minus 1, and 50 belongs to
Right.
B and 49 belongs to A. You're understanding, right, my point?
Yes, sir.
So that's what I'll just check, and if this kind of confusion is there, I'll just make sure that values are given appropriately for that. Okay.
but in general, is it not?
You can no,
one minus CL is not really practical, is it?
It will, the calculation will become a bit difficult actually with 1 minus CL.
Okay.
But in that case, suppose in this case they have specifically asked that the variability of B is greater than or not.
Greater than, yeah.
If the
that's
question
what.
is like less than or not, still if we want to take it, take the bigger one in the numerator, then we have to use the other way, na? Less than condition.
Less than condition, yeah. That
right,
that is similar, yeah. There is no change.
Okay, so basically you are saying that keep the bigger number in the numerator.
Above, yeah.
Okay,
okay. That's what I'm trying
Thank
to
you.
say. So I'll just make
Sir,
sure.
can we go back to the question? Okay. Here the last but fourth line, no? Although there was no significant difference in mean grades, can we not use that phrase, that sentence as a null hypothesis? There is a significant difference in mean grades.
Why are going to check? Because we are checking.
Why are we taking the hypothesis on the sigma 1 is equal to sigma 2? When there is a statement like this, why don't we take the hypothesis based on the mean?
Can you read the second last line?
Second, can we conclude that the level of significance, the variability of the marks in B is greater than? Okay, the question is raised on the variability. But still I hold that one. I will go back to the fourth line and means are same. Am I wrong in that? Sir?
Sir, I think sir has lost the connection.
Sir, lost
He's
the connection.
frozen.
Okay, let's have a word among ourselves now. Am I wrong in my question?
See, as per my understanding, F test is about variance, not for mean. You can just do a trial. You take any phone number, right? And choose them in such a way that their mean are same, but still variance will be different. Like you can take any, any, for example, let us take
just because hint is given an F test, F value, that's an F test, huh?
Yes, that is one thing. And then when we are comparing variance of two samples, right? We are not talking about mean. Hello? Yeah, we are comparing.
Yeah, if something is not given, I think you should not consider that. Whatever is given, we have to think on those terms only.
Correct. And F test is talking about variance only, na? Comparing variance of two samples.
No, now can we, okay, now forget about for a moment that F value is not given.
Subramaniam sir, actually the basic question I understood, sir. You got the answer in between starts from 4 to 7 kind of thing. If you observe that one, very, very small things, then you can easily understand why this is happening kind of thing, sir.
Mr. Mohan,
yeah.
Mr. Mohan, this is Anirban here. I would like to, share a bit of something here. When we are doing a testing for hypothesis, and I'm speaking only with having a quiz, the annual quiz in mind, the end term quiz in mind, we will be working with simple hypothesis for our null hypothesis. What is a simple hypothesis? It is something that completely describes a distribution, that we'll be able to conclude like if this is equal to this or this is equal to something or not, as opposed to a composite hypothesis which does not completely speak about the description or the distribution. Sorry, my bad. Am I making sense? So your null hypothesis will always be for stats 2 n term be equal to something or the other. First, are we clear on this?
Kind of, but not very comfortable.
I understand that you're not convinced. You probably